So I'm going to let X be the number of acres of wheat I plant and Y be the number of acres of barley. And I know because it's a real life problem that X has to be bigger than 0 and Y has to be bigger than 0. Can't plant negative acres, right? And then I know that I have a total of 8 acres, so the number of acres I plant for wheat plus the number of acres I plant for barley has to be less than or equal to 8. And I have more constraints. I know that for 2 gallons per acre of pesticide for wheat, so 2 gallons per acre times the number of acres per wheat plus 1 gallon per acre times the number of acres for barley has to be less than or equal to the 10 gallons of pesticide that I'm allowed total. So, I think I said that right. So 2 gallons per acre times the number of acres plus 1 gallon times the number of acres, that's the total number of gallons, has to be less than or equal to 10. Okay, so these are all our constraints, because we can't just plant fields and fields of wheat. And so let's graph them to get an idea of how many acres of each we could do. So X is greater than 0, Y is greater than 0 puts us in the first quadrant. This guy here, I can see my intercepts are going to be 8 when Y is 0, X is 8, when X is 0, Y is 8. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8. And then, but because I want to be precise, if I can get points off my graph, I will. I'm going to go ahead and say that Y is less than or equal to negative X plus 8, so that I can see my slope is definitely a negative 1. So I'm going to go down 1, over 1, down 1, over 1, down 1, over 1, until I meet, and so I've got all those lovely points, just because I'm going to worry about where these intersection points are later on, and it's going to matter, and therefore my line should be as straight as I can get it. Sheesh, that's kind of terrible, but there you go. Alright, and now for this one, if I do the same thing, I could say that the x-intercept when the y is 0, the x is 5, 1, 2, 3, 4, 5, and when the x is 0, the y is 10, so it was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But I could also do that y is less than or equal to negative 2x plus 10, and see that my y-intercept is indeed 10, and my slope is negative 2. So I'm going to go down 2 and over 1, down 2 and over 1. Looks like they meet right there. Down 2 over 1, down 2 over 1, down 2 over 1. That's that line there. And remember, I wanted to be less than both of these lines, so shaded beneath both of those lines would put us into this region here. So all of these dots that I'm shading represent possible combinations of wheat and barley I could do. I could do 1, 2, 3 acres of wheat and 1 acre of barley, 2 acres of wheat and 1 acre of barley. And this would satisfy my land requirements. I wouldn't be going more than 8 acres, and it would satisfy my pesticide requirements, anything in here. And so what we want to do is, you don't just want to do 1 and 1. We want to maximize a profit. So our profit, we're getting $5,000 per every acre of wheat, plus we're getting $3,000 times every acre of barley we plant. And so the idea about linear programming is if we want to maximize a linear equation, the maximum values of any and minimum values of any linear equation, you have to go extreme. So go to the extreme points of this, what they call feasible region, and extreme points of the feasible region will give you maximums and minimums of linear equations. So all we're going to do is test each one of these possible combinations, and one of them will give us the maximum and one of them will give us the minimum, but we kind of care about the max. So our minimum's probably there, right? If you plant 0 acres of wheat and 0 acres of barley, you're going to get 0 profit. But we could also do 1, 2, 3, 4, 5, 6, 7, 8 acres of the barley and 1, 2, 3, 4, 5 acres of the wheat. This point here, I can read it from my graph because I graphed it nicely. So this is 1, 2, 1, 2, 3, 4, 5, 6. So that's the 0.26 right there. If it was a fraction, or if you couldn't read it, you could always take these two equations to a note, substitution, elimination, to find the intersection point. This guy here, we've got the 0.50, and we plug all of those into the profit to see what we get. So here if we get 0 plus 0, we get 0, that's boring. Here if we do 5,000 times 5 plus 3,000 times 8, that'll give us something. 5,000 times 2 plus 3,000 times 6, that'll give us something. 5,000 times 5 plus 3,000 times 0, that'll give us something. Pull out the calculator or the cheat sheet. Actually, these weren't too bad to do in my head, but that's okay. So this top one, wait, where did I get 5,8 from? I meant 0,8 right there, right? That point there, 0,8. Whoops. So 0 with an 8 there, that's 24,000. And then this is 28,000. And then this guy here is 25,000. And so I get a maximum profit of 28,000. That's the biggest number there. So $28,000 max profit when I plant 2 acres of wheat and 6 acres of barley. So when I plant 2 acres of wheat and 6 acres of barley. So you can kind of see that I am maximizing my total acreage, right? I got a total of 8 acres, making the most use out of that. 2 times 2 is 4, 6 times 1 is 6, and so I'm using the maximum amount of pesticide that I can possibly use. Yay, and that gives me my maximum profit. All right, there you go.